Hi, I am Srirajani Ramkumar from Product Marketing team here at MathWorks. In this video, I'll demonstrate how to configure the TSG3 motor control timer for RH850 UTM microcontroller in Simulink and use it to control the LED brightness by varying the duty cycle of the TSG3 signal. First, let's begin with the hardware connection. Connect the RH850 starter kit to the Renesas R8 emulator. Use a jumper cable to short the first channel of the TSG3 signal to LED pin P6 of 6. Power the board using 12-volt adapter. Connect the E2 emulator to the host computer where the MATLAB is installed using an USB cable. Connect the USB or UART port to the host computer via Type-C USB cable. With the hardware connection set up, I have the Simulink model opened for this example, where I have the constant block controlled by a knob is connected to the duty cycle port of the TSG3 block. Double-click on the TSG3 block to see its block parameter. Select the TSG3 module. Here, I am selecting TSG31. The TSG3 module accepts the duty cycle input for all three channels, and we are interested in the first channel which we will be using to control the brightness of the LED. Thus, the constant block connected to the duty cycle port of the TSG3 module has a dimension of 1x3 and the duty cycle is represented in percentage. Hence, the knob is configured to range from 0 to 100. Now, let's open the configuration parameter by pressing Ctrl E and go to the hardware implementation tab. Select the hardware board and device series. Now, expand the target hardware resources. Here is a placeholder to include the CDF file generated from any third-party tool which is used to configure the peripherals. For this demonstration, you can import the default CDF which has pre-configured DIO, GPT, port and MCU modules to initialize the board with necessary clock settings. By clicking on Input and selecting this ARXML, you would be able to see the default CDF imported in the working directory. To configure the TSG3 signal pin, open DaVinci Configurator. I have created a new project and imported the default CDF from MATLAB working directory. For the TSG3 signal port configuration, you can see from the pin function that port group 10, pin 1 to 6 has the alternate function of TSG31. Enable the input control and select the pin initial mode to TSG3 for all the port pins 1 to 6 under port group 10. Now to configure the user LED, go to the corresponding port and pin number which is P6 of 6. Go to port group 6 and select port pin 6. Set the pin direction to input mode. To configure the channel for the corresponding port, add DIO port container if needed. By default, the DIO port is added and configured for port group 6, under which you can configure the channel 0 to 15. Now to configure a channel, add a channel container. By default, a DIO channel container is added and configured for channel bit position 6. Thus, pin 6 of port 6 has been configured as an input and the TSG31 output from the first channel, pin 1 of port 10, is shorted using a jumper cable which allows us to control the brightness of the LED based on the duty cycle of TSG31 signal. Having these configurations done, now let's export the setting and generate new CDF file. Once exported, return back to the Simulink configuration parameter and browse to locate the exported CDF to include here into the model. Next, go to TSG3 and enable TSG31 configuration. Under Connectivity tab, enter the COM port number. This COM port number is used for communication between the FTDI and the host computer, and it can be found under the Windows Device Manager. Finally, to enable parameter tuning of the Simulink model, go to Code Generation and under Optimization, ensure that the default parameter behavior is set to tunable. Otherwise, the user will only be able to monitor the signal and not be able to tune the parameter. Click on Apply and OK. With all these configurations done, now let's run the model in the Monitor and Tune mode. As the model runs, let's quickly change the duty cycle knob. As you rotate the knob, you can see the brightness of the LED changes instantaneously. Hope you have learned the basic settings required to generate the TSG3 signal. And thanks for watching this video.